Hello to UILCS coders. In this video, we're going to cover the hash map data structure in Java. So what is a hash map? A hash map is essentially a map that has no ordering of elements. Alright, just follows no order. Now you might be confused by that because, well, first off, what is a map? We haven't covered a map yet in this series, right? Well, a map is a data structure that stores entries. Then what is an entry? Well, an entry is a data structure that stores key value pairs. So this is actually what an entry, like my visual representation of an entry. So as you can see, it stores key as a value, like a variable, and it stores value as a separate variable. So what do I mean by key value pairs? Let me sidebar this. So we have this key, right? When we say key value pair, we mean that this specific key points to some specific value. Now this key can be anything. I think a good example of this is a dictionary and maybe the word apple. So when you find the word apple in a dictionary, what the definition is probably like a fruit. So I'll just write fruit. Fruit. An apple is a fruit. So in this case, the key is an apple and the value is fruit. Because when you find the key apple in dictionary, it references or it kind of points to, right? It'd be like maybe like this, and then the words would come after. But it points to this value. I don't want to say points to. I'll say like it's associated. It's related to this value. They're paired. You can't. You have the key and the definition. You have the apple and here. Okay. So, but what does a key value pair even really mean? Let's take the example of a dictionary. So let's say I'm looking at the word apple. Well, in the dictionary, you might see that it defines an apple as a fruit. Maybe you'll say. How are apple and the fruit related? Apple and a fruit. You can say they kind of pair together, right? The apple and its definition in a dictionary, right? They're next to each other. They're kind of paired, you could say. And then in addition, you could say that you need this definition, or you need this key apple to even be able to find the a fruit definition value, right? So all this is what a key value pair is. The key is associated with the value, and you can use the key to get to the value. Now, I'm not saying that the variable key is a pointer to the value. Key is not a pointer. It can be any object, and then internally, it can be any object, right? But it still has a relation. It's still paired with this value. They're kind of stuck together. Right, so if you want a dictionary, you can search up apple, and you can find its definition like that. That's what a key value pair is. So if an entry is just stores some key, some value, and then so what is a map? Well, a map is just a multitude of those. It's a data structure, right? So you have a bunch of keys and a bunch of values. Now, then what is a hash map? A hash map takes us one step further. So here I have an example. So we have a bunch of indexes of an array, index 0, 1, 2, 3, 4, all the way to the array's capacity. In each of these arrays, we hold a linked list. You may be saying, okay, so what's in the linked list? Well, inside of here is an entry. So in each one of these linked list elements, we store an entry. So write out entry, right? Entry, 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 and so on. Right, so that's what a hash map is. It's just a linked list, and in each of these linked lists we have entry. Now what does this mean? Okay, why are we even doing this? So right here, a better question yet, how does this process even occur? So the way hash maps work is you'll pass in some key, some value, right? Let's say I want to add maybe let's say we're looking at a hash map of this apple or fruit. Maybe you have a hash map of a dictionary, and these are all empty right now, right? We have our array, and in our array we have the linked list, but all the linked lists are empty, so I'm just gonna say that's empty. And then I want to add in, maybe this would be a hash map or plain a dictionary, and we don't have a, I guess apple is a fruit. We don't have a definition for apple. So I want to I want to add in apple, and then I also would like its definition a fruit. Now you're not gonna have to pass in an entry. You're not really gonna do that. This would be like a call to a method. In particular, this is the put method. That's all you're doing. Essentially, we're calling this method. It is the put method. So if I wanted to take this apple or fruit in, first we'd look at the key apple. We would do this process called hashing. So we'd hash it. Now, of course, hashing requires two things. It requires whatever. So basically, with hashing, we call the apple, which would be a string, its hash code. So we look at the hash code. I think the full operation would be like if A represents the element we're looking at, A dot hash code modulo, and it should be our capacity. So we can do some array loop, modulo looping, which we talked about before. Yeah, okay, so this is what we call this modulo looping. So essentially, whenever you take the modulus of something, the answer is always going to be less than or equal to capacity. So you can never go above, or you can never go above your second, I guess your divisor here. And so this is really useful for us in getting these elements. Because we can never go over capacity, and that's like our limit, then we'll always have some index to put this in. So we'll run this hashing function on Apple, and then what I say that gives us an index. So we go to that index, and then we'd add a new entry. So if this is empty, remember we're going to add a new entry. So here we'll add an entry. Inside of that entry, we have to give it an apple. So here is going to be this representation, right? I'm going to say entry. So now we have an element in this linked list. And I'm just going to say that apple hashes to 0. Anyways, let's zoom in on this entry. Right? So how are we going to do this? Well, we're going to first make an entry that has a key of apple, and then a value of a fruit. So I think that was a little bit confusing. Let me go over it in an easier, simplistic way. First, you hash the function, which is where you get its hash code and then modulus it by capacity. You take the absolute value because the hash code can be negative, and then you can't have negative indexes. So, anyways, what will this give you? This will give you the index. So you can say the index that we're looking for is the result from this map. So okay, boom, we have an index to place this apple or fruit in, but right now it's just two strings, right? We just passed in a string, an apple, a string of fruit. And I said that we needed to be an entry. So we're going to create an entry with the key apple value fruit, and then we're just going to add that entry into the index, 0, or whatever index gets returned by the hashing function. Why do this? Why do we do this? What's the point of this whole system here, right? What hash map benefit in is time complexity. So when you add an element or inputting, or when you remove an element, and then when you search slash get, or not search is always pretty much O(n). But if you want to get a particular element, using hash maps and other hashing data structures will give you time complexity of O1. This is because your elements get split up into these various indexes. So you never really need to go even to O of n time. And you can you always know which key the value is. So I wouldn't say something like it's logarithmic because you know which index to look at. So you'll know, hey, I need to look at this index, I need to look at that index. And that's looking at that little tiny subsection of all the elements you passed in. So we essentially just say it's O1 for these tree operations. That's the important fact to understand here. Okay, so now we have a good understanding of the hash map. Let's go over some methods. So where do I want to put this? Not really liking this current layout. Let me take all this stuff and I'm just gonna move it here. And then let's just expand outwards. Okay, we by no means are gonna need all this space, but I don't know, it's fine. We can use up some space, it's okay. So let's go over the methods on the hash map. So the first method I would like to talk about is void clear. So this is generic. All your collection interface, all your collection framework classes will have this. This will clear, or I'll say this will remove all entries. So remove all entries. Okay, moving on to the next one. It's going to be clone. It'll return an object. Clone. Again, it'll take in no parameters. So what clone will do is it'll essentially create we call a shallow copy of hash map. In this case, it's hash map. It's really whatever data structure you're using. Just why we don't, because we're inheriting this from the collections framework, it's why it has this. Because we don't know if, or I guess the collection interface, we don't know if it's a hash map, if it's a hash chef, it's a tree map, if it's a queue, or no, queue's not a part of this. Tree set, etc. We don't really know. It could be any one of these data structures that we are putting in, or that we are using clone on. That's why it returns an object. So you've seen put already a little bit. So put here. The next method to discuss is the put. The put method will return a type v. It'll take a type k key, and v value. So I'm just using generics here. So all I'm saying is that we're going to be returning a value. And so what put does is, and I'll shrink it to 100. And let me take all this stuff, just move it back a bit. So what put does is it kind of inserts key value pair as an entry in the hash map. So this doesn't need much explaining. This was what we saw when I took apples or fruit and I put it in. It's just doing the hash code, getting the index, and I'm putting this as the first or the head element of that linked list. Now the return we'll talk about. So because if, I'll do this part in red. if value already at key. So let's say I inserted apple as a fruit, and then I wanted to insert apple is tasty or something, right? If there's a value already at that key, so we're gonna override the value and return the old value or null. So return null if the key wasn't existent. Or like if this is your first time making the key, right? There's no previous value to get, so let's just return null. Otherwise, hey, I'm inserting a key, I'm trying to put an apple, the apple is tasty is my value. Well, hey, apple is already a key in our hash map and it has the value as a fruit. Let's return it's a fruit, and so that way in case the user wants to use it, they can. Right? Okay, the next method is going to be void put all. So what put all does is, so it'll take in a map of entry, and then the entries themselves will be k, comma v. So taking a map, I'll say map, and what this does is it just simply like puts all entries in. So all entries from map into hash map. So taking all these elements or all these values from the map that you passed in, and it'll just simply add them all to our hash map. Okay, so that was put and put all. Now there's one more called put if absent. V put if absent. So this one will take in a key and it'll take in a value. So I'll just leave it like that. And it'll do put if and only if key is new. And what it returns the same returns as put. So essentially, if the value doesn't exist, this will return null, indicating, hey, we just made this new value. Otherwise, if it does exist, it'll return that value instead. So that's put if absent. The next method we need to discuss is the remove method. So it will return a type of v, and it'll take in a key. And what remove does is what's in the name. So remove entry that stores key. So there's an entry that has that key. It'll remove entry that stores the key and return its value. The reason why I'm focusing a lot on returns here is because they'll test to make sure you actually understand what these different things are returning. So return its value, right? That one, pretty self-explanatory, I feel like. The next one is going to be a Boolean type. It's going to be Boolean remove. It'll take in a key and then a value. So this is more specific than this, right? So remove entry. It'll remove entry if key and value match. So if key and value match. So right in our example, if I had a hash map containing apple is a fruit, right? So I just have entry apple is a fruit. It's inside of my hash map. If I did remove apple, this would remove apple, return as a fruit. If I did remove apple as my key is a fruit as my value, this would remove apple and return true. If I did apple is a potato, this would return false, right? The key was there, but the value did not match. This is a more specific type. We want more information, so we will return a Boolean. Okay, the next method to talk about is the replace method. So we'll return a value, the old one that has been, or like the old value at this key, and it'll replace. Oh, well, obviously you need to pass in a key too, or value too. So this will replace value at key, and it'll just replace it with the value you've passed in. Will return old value. So I'll say we'll return previous val. Right, and this makes sense, right? Because we don't want to lose it. We don't ever want the user to like lose information, right? Which is why I put return the value in case we're actually going to override this key. Let's return the old value. Same idea here. But we're replacing that value at that key, so let's return the previous value. And this one also has a more specific type. So this one's more specific type is going to be a Boolean replace. So it'll take in three parameters, k, v, and then another value. I'm just writing them out because it'd be like this, right? K key v value. I'm not gonna write it down. I'm just gonna say it like this. You can connect the dots. So it does replace if key and value match. So again, this one might be important to specify. We're talking about this key and this value. So this represents key, and this is your old value, and this is your new value. So if you're familiar with this, I might be able to say this is v not, and then v final. Your old value and your new value. So it'll do to replace if your key and the old value match. So if it finds an entry with this key and this value, it'll replace this value and make it VF. Right, and it'll same idea. If it does successfully replace, it'll return 2, otherwise it'll return false. Now there's one more replace method, and that is the replace all method. I guess a pattern, the replace all methods return void. Replace all. So replace all takes in a by function, and in this by function you'll pass in a key and a value, and then it's a by function we need to return a value too, so kvv. That's this weird by function. What even is that? Well, I'm not gonna answer what a by function is in here. We have a UIL lambda and functional interfaces video that should be coming soon. They'll go over that. But what does replace all do? So it'll goes to every entry every entry, replacing result or replacing value with result of apply key, comma, value. Alright, so this will go through every entry, replacing the value there with the result of apply key, comma, value. Alright, you don't need that, sorry. Right, so well, that just makes sense then why we have a return on by function as a value. Because if this apply function is going to become a new value, then it makes sense that we needed to return a value. It can't return a wrong data type, right? Everything's generics here. If our apple is a fruit, right? In that example, if our apply function returned an integer, that wouldn't work because we want apple to be correlated with another string. Okay. The next method to talk about, and I think we're actually almost done. Well, there's some here that we need to talk about. The next method that I want to bring up is the put method, compute method. It will return a v, compute. So compute will take in a k key, and then it'll also take in a by function. I'll just write by f. Just remember that's a by function. So what does compute do? It'll go to that key and replace its value with apply with apply result. So, and this will return the new value. It will not return the old key. It will go to that key and replace its value with the result of the apply function, and it will return the new value or null. There's one thing I want to talk about. So if your key doesn't exist, it will create a new entry following this idea of the key and then the result of, so creates a new entry of apply key, comma, null. So it's like whenever k key that you've passed in, and it will return the new, or create a new entry, make it the head of the linked list, and that new entry's value will be the result of apply and then null passed in the value, obviously, because there's no value for you to use. We'll just use null. Now there's two subforms of this. There's v compute if present, which will just do this first half. Right, it'll take in a key and a by function if, and so this will eventually do the same thing as this part. We found the key, replace its value with the applies result, and then there's another form, the compute if absent. Compute if absent. So compute if absent does, it'll take in a key and a by function yet again, and it'll essentially do this. Now, There's a special thing to note here about the returns, right? If you're trying to pass in a key that doesn't exist, it'll not create a new key. It won't do that. So no new key will be created with computer present. It'll just return null. Same idea with computer absent. If your key does exist, then, or it is specifically just doing this portion. So we're not going to like do any of this. We're not going to go to that key, replace its value with the result of the apply function. No, we're just going to return the new value still. So we're going to, I'll just write here, returns current entry value if key exists. So either way, still the most updated value, which is what compute returns, the most updated value, right? It'll return the value of apply key comma null if your key didn't exist. It would return the value or the result of the apply function if your key did exist. And then the only major difference is here for commutative absent, it'll return the current value if the key does exist for commutative absent. But even then, it's still the most updated, most recent value for that key. Those are the computes. I'm really just specifying on the return types because if you understand what compute does, you understand what these do. But return types you might forget, and I don't want you to forget them. The next one is merge. So there is only one for this. There's no merge fast and merge present. Merge will take in three things. It'll take in a key, it'll take in a value, and it'll take in a by function. So again, I'll write BIF. So what merge does is it'll essentially compute, it'll do a compute. It'll take return set value at entry k with value, or not value more say, but result of apply. Now I'm going to write this in red because this apply has different parameters. You can look at this as primarily just focusing on the value. Merge primarily focuses on the value. Or if you even look at it as maybe you merging in two different values. Merging in the old value, merge the new value. This would be current value. And then I'll just say v for the value that you've passed in. So it'll return the result of this function, or this apply. And then what does merge do? It'll just return the same idea as compute. So it'll return most updated value. Now because then this will still create a key. So still creates a key. So you can see a lot of parallels. Still creates key, but uses v. So we're going to use the parameter that we've given. We said parameter v, we're going to use v. Is there anything I'm forgetting about this method? No. That's essentially it. It's basically compute. Pretty very similar to compute. The only difference is you're messing with its values in the apply function. And when you pass in a key that doesn't exist, it'll create that key using this value that you've passed in. Okay, there's two more that I'd like to go over. They're very straightforward. They are the we went really far. It's the Boolean contains, or there's a few more. Contains key, and then the Boolean contains value, and it'll just return true or false. It'll take in no parameters in either of them. It'll return true or false depending on if this is stupid. This should return. This will take in a key k. This will take some sort of value, because obviously you kind of needs to. And What this will do is it will return true if the key is found, return false if it isn't found, return true if the value is found, return false if the value isn't found. And they are both of O n time complexity because you have to essentially, worst case, you're looping through the entire array trying to find this value. So there's one last function, the very last one that I want to discuss, and that's pretty cool, right? I talked about how there's all these entries, right? You can take these entries and we can make a set out of them. So this will actually return a set, and the type will be map dot entry because entry is a class inside of map. K comma v, and then this one's that. But it's in the name, right? It'll just return a set of the entry values. Right? Each of the elements in the set are just going to be an entry. That's essentially it. Not too complicated. Maybe you guys realize a different way of looking at it, and if maybe you wanted some set functionality, you could use that. One more thing I would like to discuss about a hash map, and you probably have seen this, is the idea that keys can't be duplicated, right? If you passed in a key to put and you pass that same key again, the value at put that key would change. There would not be another key. So a principle in maps in general is that the keys can't be updated or duplicated. They can be updated, they can't be duplicated. Okay, so now we've covered a bunch of these methods. Let us simply just create a hash map. I made one in the past, I called it the SID hash map. This is my second time doing this video. The first time I got some stuff wildly wrong. Yeah, I just finished making my, well, this was actually part one of the graphs video. We're gonna go, where is it? SID hash map. A little bit of spoilers. Let's yell at this. We're gonna create our own SID hash map. Well, this was my own SID hash map. We're gonna create another one. Okay, let's make this function. Alright, let's create a private int capacity. This will store our capacity, and I need a class. I need a entry class, right? Because I need a way to get my entries. And I said like a few minutes ago or something that entries are a inner class hash map. Let's just make one. Okay. Why is it tweaking? And stop complaining, bro. Let's get to work, buddy. We're gonna need a private. I'll make it all private, so only this class can use it. And I mean, public class will also be able to use it, but you can't go outside. Private int key, or make it strings. Or well, actually, it should be k. We're doing generics, right? Public entry of some key of some value is equal to assign it corresponding to that value. Boom. Nope, this should be key, right? Look, we're already getting that error because the types are mismatched. Alright, so let's create a public, it won't be void, v, I'll call it put. We're not going to create any of the subsets of put, just put. What did I say put? Put will need a key, will need a value. First, well then by extent, we need to create a public, I'll make it a private int hash, which will take in a key, and then we will return the math.absolute value of key.hash code, and modulus that by the capacity. Right, modular looping, discuss that. So we're going to take an int index is equal to hash of key. Okay, then we can say, well, we're not going to do an if. We're going to go for int I is equal to 0 while I is less than But wait, we haven't really created our data structure that will store in our linked list yet. I'll do that up here. Private linked list buckets. And this will really, we need some generics here, but you can't really assign generics like this. Like you can't do something like this and then try and make generics, so we're not gonna worry ourselves too much there. Let's go here. So I is going to be less than capacity, I plus plus. I want to go to buckets at index I. And then, so this will be some loop. So it might be better is if, oh, I understand it. Okay, boom. Let's go to, where's pudding, right? So I just want to go to the buckets at index I, or index, and then this is a linked list. So let's add first a new entry containing this key and this value. So this is just the adding, right? We're adding it as a head. But I would like to go, before I do that, let's look at the v value right here. I'll say the current val in the buckets at the index that we're looking at. We're getting an error because we didn't use any generics. I'm just gonna say this is an object. That has to work. If current val, or if the value that equals this current val. So you can also see that for hash maps, not only do you need a hash code in your object, you need an equals method, right? So you need both of these methods in order to have a hash map. So if there is, or I should say, key dot equals key key, okay, wait, I messed this up just a tad. Let's run this again. So this will be a linked list of entries, right? Like this. This is how we define a linked list of entries buckets. So now we can, so now what I'm going to do is I'm going to go to for every entry e in my buckets get buckets at index. It should work. Yeah, it does. And now I can specify, I can pass in k comma v here. Same thing in here. If that's why it's tweaking, I'll pass in the k and I'll pass in the v. That's just the wrong, that's still the wrong sign. Cool. Now generics are matching up and everything's looking pretty nice. Let's see if e dot key is equals the key passed in. I need this to be an if statement. If this is true, we said we wanted to just still update it anyways and return a new value. Wait, then we don't even need this. This is so irrelevant. Waste of time. We'll worry about that later if I replace maybe, but here all we can just do is we can just go to our buckets, add some index dot, let us add first new entry of the key of the value, and then we're going to return value, right? Because we don't need to, even who cares, nobody cared if we replace it, like, or we're just going to replace it anyway, so there's no reason for me to go to looping. That should be put. I don't think there's any more hidden complexity behind put. It's really straightforward. Public v remove. So again, I want to take in a key. I don't need a value. I'm not going to make the Boolean type. Index has key. So first off, we need to actually find this key now. So this time we actually want to look at each entry inside of our buckets, uh, inside of our linked list to be more specific. And then if e dot key dot equals key we've passed in, first you want to remove that. So we can, maybe I can say that buckets, or no, this is irrelevant. Variable here will say buckets at index dot remove e dot key, or remove e. There you go, boom. Right, because our linked list is made up of entries, so if we can just remove the corresponding entry. And again, you might be saying, okay, well, this is have on because remove in a linked list is an on time complexity. Not necessarily, because remember that our elements are getting dispersed throughout a bunch of different indexes, so you don't really have on. Maybe if you're looking at that particular linked list, then yes, on, but we're talking about the hash map as a whole, not just the list. So that'll handle that. And then the last thing is we want to return the old value. So let's say that if we find it, I'll say v old value is going to equal to e dot value. Otherwise, let's return null, meaning that, yo, we just didn't find it at all. So there's two more methods I want to make. I want to make the compute method, which will return a value. Well, it will have that. We'll have a by function, particularly of the type k, v, v. I'll call it the remapping function. Let's put like this. So following camel case. Okay, so what do we need to do? We need to find the index. That's always a good starting point. If this entry exists in our bucket, that's some index, right? This is standard stuff. We've seen this. We're finding this, right? Okay, it exists. We need to replace it. Set e dot value equal to the call apply of e dot key, e dot value, and it's not really apply. It's mapping function dot apply, right? And then let's return e dot value. So we can just do this. E dot value in life is good. Now, that's not entirely true, because what if we don't find it? Well, then I would like to go to buckets at index. We could call put. Let's do that. Let's use some of our own methods. Let's put in a key, k key, put a key. And then the value of the key we said should be the by function. So remapping function result of giving the key and passing in null. It's hating on me, but why? Because it's not remapping function, it's remapping function dot apply. There we go, life is good. Then let's return buckets index dot peak dot value. It's not agreeing with me on this. This won't be null because our index will exist. And this won't be null because we just added in this key here. No, but what if this gives us a value of null? That's a fair point. There's one more case I forgot to mention. So let's maybe not do this because for the code, it'll make it more better for us if I just say like maybe like this. Bucket index dot add first. Just so you understand what's really just going on here. E dot key, comma, remapping function dot apply e dot key, comma, value. Then none of these exist. This should be key. This should be null. This should be key, And then even then, this needs to be all wrapped inside of a new entry. Add a little bit of our generic keys in there. Okay, so I'll handle that, and then I want to return the result. So what I'm gonna do is I'm gonna take this call here. I'll say view value is equal to the result of this. If value is equal to null, return null. Otherwise, we can just set the value here, and then we can return value. So that's good, but this we need to also do this here too. So maybe if e dot value is equal to null, so if our mapping function made it null, we need to call remove key. Let's remove that key. So why are we doing that? Well, a part of the design that Java had for compute and merge as well is that if your apply function, or if your mapping function is able to return null, that's you telling the code, hey, I don't want this key anymore, delete it, get rid of it, remove this key. So we have to implement that feature, which is why I'm doing that, and this why I'm doing this. We can delete this. The most recent value is what's being returned. So let's create the last one in public, the merge, it's going to take in a type of key, take type in a type of value, and then I also would like a by function of what value, comma value. I'll call it remapping function because that's what it is. It's remapping function. I can duplicate like most of this code, like I said, compute and merge are very similar. So all of this is true. All of this is true. Why are we complaining? Yes, that's a very good reason to be complaining. Right, we set in our apply method. We want this, and then we want to pass in the value here. If it's null, again, remove it. Otherwise, return the new value. And then here, let's say value, return value. And then we'll do this, we'll do this, we'll do this. With a good result of doing the not the remapping function, because you can't do the remapping function. Oh, there we go. I had a little error in my explanation. Let's jump back to here. So if we go to merge, yeah, no, it didn't. Now it's right there. Never mind. Here, here. Return value. Don't worry about that in this case. We're never gonna call the by function here. Let's create a new key with the value, return value. There you go. So why did I delete all this? Because in merge, when the key doesn't exist, we just create a new key with this key and this value, and that is that. Obviously, you're not passing in null there or something, and even if you were, you'd have no key to delete in the first place. There's no reason to have delete checkout here. We need one in here because, again, we're working with the mapping function, and I said if the mapping function returns null, we want to delete that key. Okay, oops, I forgot something. Yeah, no, my initial instincts here were correct. And I started going G, K, comma, B, E, in the bucket index. Because look, so let me explain my flaw here. I said that we cannot have duplicate keys in a map, right? This was known. If you pass in the same key twice here, you would actually have two separate entries with that key, right? You're simply mindlessly adding it. No, if the key that equals the key that we passed in, let's replace the value, key that. So return the most updated value, right? or no, we said we would actually want to return the old. So the old is equal to that value, and then I'll simply return the old. And then over here, I just completely skipped on the key check. I guess my brain just had it assumed. Remember, first thing we need to do is find the key. So we need to find if this key even exists. I think in my brain, I just assumed that I did that when I actually, in fact, did not do that. We're missing that for this one too. And then this last one is kind of just a minor thing, minor fix, generics. And I'll just listen to this guy, make it a static class. Oops, and wait, did we initialize our buckets? Why are we getting this error? Oh, it's never assigned. That's the problem. Where's my constructor? Constructor, there is no constructor. There you go. Public sid hash map. Taking in nothing. Or maybe I actually wanted the capacity. I make a capacity and I'll just create buckets is equal to new linked list array of capacity. Generics maybe? Yo, why are we hating? Stop the hate at once. I don't want to do that. Let's leave that. That's fine. Who cares? Who cares? Who cares? We have the bucket assigned. We fixed that. I was wrong here. I said it returned the old value. That's not true. Or no, I was right here, but here when I returned value in our notes, we said it would return the old value or null, right? I just mindlessly did value because everything here, I'll return value. Put will return null if it's able to add it in. And that makes sense because you already know what value you're adding in, you don't need that back. Alright. Okay, the last thing we need to do then, we haven't fixed yet, is we have no initialization of our buckets. That's a problem. I did skip over that. I used buckets. My usage of it is right rather than initializing. Let's set the capacity. The set capacity equals capacity. So just your normal stuff. Let's list that buckets then. So equal to a new linked list array of capacity. Now, is there an issue here? Can I just leave this and go? Yes, there is because we're creating a new thing here, right? So if we're thinking about it, we have an empty array right now. We have an empty array. Whenever you have a generics or an object passed in, like if I had a string array, what is it initialized to for all of your elements? No. So am I safe to say that every element is a linked list right now? No. Every element in the buckets array is currently null. So we need to loop over in zero while I is less than capacity I plus plus. Let's go this bucket at I is equal to a new linked list. There we go. So that should be everything. Oh, did we cover retrieving? There's a get method. So v get, right, it's a key, it's a map. You need to be able to access your element. So be like v get is equal to, or inside here put in a k. This will return v or null. But then there's another form which is get if present, a get or default. Not get if present. I was thinking of compute. It's called get or default. which will return return a value, take in a key, and you'll pass in some value v to return value at key or v, the value we've passed in. Let's set up a get method. Public get. You can't call yourself a map if you can't get element. Hash of key for, or let's just go to that in or we can just do entry. Let's follow our same instruction of the buckets at that index. If e dot key dot equals key, return e dot value, else return dot. There we go. So we're getting an error. Why? Because I said entry. I have not given this entry any parameters. There we go. Generics. Generics are done. Life is good. Right, so the compiler has no way to understand the value, and also because if we just did entry, I'm pretty sure we were using like maybe it's an import somewhere, but we were using like a normal entry that it was using ours. I guess you just need when you have a generic thing, you need the generics to actually tell Java, and that is our get method. So that is everything. Let's check our get method. Okay, cool, cool. Thank you for watching the SID hash map video, or just the hash map video, not the SID hash map video. Hash maps are really cool, and if you know this, I'll explain. Then you know hash sets, hash sets, linked hash maps, and linked hash sets just by knowing this. So the next few videos should be very easy.